answer? So if we say that the force must be exerted on, yes, very good. Answer is option 1. That means we have to take the whole thing as a system. The whole thing as a system. So you know that whenever this man is going to pull this string, so that force with which he is pulling is going to be translated as the tension, right? So if we'll consider the whole thing as a system, and here it is tension T. So we can show that this one is tension T. Here also it is tension T. So if we consider the whole thing as a system, so we can show the forces like it is 2T, and here it is going to be M. M is the capital M is the mass of the frame and small m is the mass of the man. So we can write M plus M into G. So these two things needs to be equal and opposite, then only the system will be under equilibrium. Excuse me. M plus M into G. So tension is equal to M plus M into G divided by 2. So the final answer is option A. Answer is option A. We'll gradually go to the difficult ones. Okay. Now the next one is here. We are required to find out the minimum time in which the car can cover the distance is proportional to what power of mu? Yes? No, no, it's not B. A car is starting from rest to cover a distance S. If I say that this is a car, right? And it has to cover a distance of S. But coefficient of friction is there. So coefficient of friction will be opposite to the direction of its motion. Right. So this is frictional force. It has to cover a total distance of S. That means at this particular point, the car will be at rest. Its final velocity will be equal to 0. Right. And the coefficient of friction between the road and the car is mu. We are required to find out the minimum time in which the car can cover the distance is proportional to what? Is proportional to what? So how to do this? See, first of all, we have to find out that what is the time. As you know that other than this frictional force, no other force is applied over here. So the retardation has been caused due to the frictional force, which is equal to frictional force divided by mass. So what is friction? Friction is mu into mg, normal reaction divided by m. So see, acceleration is coming out to be mu z. Acceleration is coming out to be mu z. So let's write down the equation, that is S is equal to ut plus half at square, right? Initially it has started from rest. So initial velocity equal to 0. So we can write the time is equal to square root of 2s by a, square root of 2s by a. So we can write down the time is equal to square root of 2. S is the displacement, acceleration is mu into g. So we can write down T is inversely proportional to 1 by square root of mu. Because S is constant, G is constant, 2 is a constant. So final answer is option D. Final answer is option D. Now question number 27. It's a very nice question. We should try it, right? A block of mass 1 kg is horizontally thrown with the, I think everyone is clear with the situation that has been described over here. A block of mass 1 kg is horizontally thrown with the velocity of 10 meter per second on a stationary long plank of mass 2 kg whose surface has a coefficient of friction equal to 0.5. Plank rests on a frictionless surface. That means the bigger plank is resting on a frictionless surface. Right? We can show it here also. This is a big plank which is resting on a frictionless surface. Draw the situation. This one is a block which is horizontally projected on it, which is horizontally got projected on it, right? With a velocity of v. Its mass is given as 1 kg. Yeah? Its mass is given as 1 kg. And it is kept on a stationary plank of mass 2 kg. So the plank's mass is given as 2 kg over here. But friction is present between the plank and it is. Friction is present between the plank and the block. So here we will have friction. Okay. So if this part is rough and this is not rough, like this is a smoother one. So what will happen? Let us talk about the block which is kept on it. If we'll talk about the block, we will find that as the block is getting projected towards right, so the direction of friction on it is going to be towards left, right? So immediately we will get another part of this pair of this friction on the below block that we will show later. So this one is moving along this direction. Let it be with a velocity of v naught or speed of v naught. Now the acceleration will also be created towards left. This is the acceleration, right? How much is the friction? This friction is between 2 and 1 kg. So we are going to write down this friction is equal to 1 into mu g, like mu into normal reaction. I'm going to write this normal reaction as N1 over here. This is my normal reaction N1, right? So mu N1 is equal to, and we can write it as M1. This block is named as M1 and the below block I'm writing it as M2, right? M1 into A1, M1 into A1. So I can write mu N1 equal to M1 A1, right? So we can write acceleration of the upper one is coming out to be mu N1 by M1, right? So mu is 0.5 into normal reaction is 10, mass is 1. So A1 is coming out to be 5 meter per second square. A1 is coming out to be 5 meter per second square. Now let us look at the second one. I mean the below block, the big plank. I'm talking about the long plank. So if we will show the long plank, then we will, let me show all the forces on the long plank now. So this is our long plank whose mass is 2 kg. So what are the forces are there? You know that it has only one force that is acting on it, which is the reaction pair of this. So this is F. So its acceleration will be along this direction. So I'm going to write this acceleration as A2. I'm writing this acceleration as A2. If F is equal to 2A2, F is equal to 2A2. Friction we have already calculated it as. So friction is going to be mu M1G equal to 2A2 and mu is coming out to be your 0.5 into 10. So this is 5. So we got the acceleration of the below one is coming out to be 2.5 meter per second square or 5 by 2 meter per second square, right? So this is our A2. Question says you that the time when M1 comes to rest with respect to the plank. When M1 comes to rest with respect to the plank, right? So that means we have to find out the acceleration of M1 with respect to plank. So I'm going to write down the acceleration of the block with respect to Planck. Block with respect to Planck is equal to acceleration of the block minus acceleration of the Planck, minus acceleration of the Planck. So I can write down here, see what is the acceleration of the block? That is A1. That is in the backward direction. That is in the backward direction. Right. So we can write down AB minus AP. So that one is minus 5 minus of, and Planck is moving in the forward direction, minus of 5 by 2, that is 2.5. I'm writing, if I want to just write down the magnitude of it, so that is coming out to be 7.5 meter per second square. That is 7.5 meter per second square. We are required to find out the time in which M1 comes to rest with respect to Planck. So we'll be using this equation B equal to U plus AT. U plus AT. So final velocity is coming out to be 0. What is the initial velocity? Let it be U. We don't know this. U minus of ABP into T minus of ABPT. Right, already we have found it out. Right, so we have already calculated this value. So let's see. So what is the answer coming out to be? This is 10. So 10, 0 is equal to 10 minus 7.5 into T. So we can write 7.5 T equal to 10. So T is equal to 10 by 7.5, that is 75 by this. So we will do one thing. This is 3. So answer is 4 by 3 seconds. Answer is 4 by 3 seconds. So this is the answer to the question. Right? Yes. Some of you have only one gave me a correct answer. Anyways, that's absolutely fine. Day after tomorrow onwards, I'm going to schedule the class in the morning. It may be possible. I'll let you know. If you have some concern, please text me personally that if you. Right. Question number 28. Do it. This is again a very conceptual, amazing question. A board of mass 1 kg is lying on a table and a weight of m equal to 2 kg is lying on the board. Actually, this is road, under the road. This is a road actually. Similarly, exactly in the same manner, we have to find out the coefficient of friction between the load and the board. I mean, a road and the board. This is the board. And what should be the value of friction over here, so that we can say that the between the road and the table, the coefficient of friction between the road and the board is given, and the between the board and table is mu2. We are required to find out what should be the minimum value of this force, so in order to pull it out from the road. So you need to show that all those kind of forces. See, first of all, if I say that if you pull it, so the most difficult thing that the student face while doing this kind of question is that where to put the show the friction on the upper block or the lower block, right? If you pull it, so this block has a tendency to move in the backward direction or in the forward direction. If you pull it, the body will have a tendency to move in the backward direction. So the friction on this block is going to be towards right, right? So I'm going to write it as friction 1. So similarly, it will have a component of it on in the towards left and the lower block, that is F1. And similarly, as you know that if you pull this, so the system, the whole thing will have a tendency to move in the forward direction. So we will be getting F2 over here, right? So gradually, let us start it doing one by one. We will start from the upper block, that is M. So this should be always the first step, that we should draw the free body diagram of the block, and that block is capital M. Let's draw the free body diagram of this capital block M. So it has a weight of 20 Newton, whose mass is given as 2 kg. So it has a weight of 20 Newton. Then we have the normal reaction, that is, let it be N1. And as you know that I told you that if you pull it, just as a layman, you think that when you pull the whole system, if this block slips ever, then it has a tendency to slip in the backward direction. So that's why the friction that is acting on it is equal to F1. And where this friction is acting, this is acting between M and M. So how to calculate it? Mu times of N1. Its limiting value is calculated as mu times of N1. And mu1 actually, mu1 is 0.25. This is the maximum value of F1 is 0.25 into normal reaction. And here the normal reaction is 20. So 0.25 into 20, very carefully we have to do it because there are two frictions, so we may get confused about it. 5 Newton. Similarly, we can also find out the maximum value of this friction. So I am writing here instantly the maximum value here itself. F2 is coming out to be mu2 into N2. And as we know that what is the value of N2? Is the normal reaction between at this point. We can directly do it like it is going to be M plus M into G, and this one is your normal reaction N2. Though it is, if I'm taking it as a system. So here M plus M is 30. 3 into 10 is 30 Newton. So 30 into 0.5, that is equal to 15 Newton. So this is the limiting value of the second friction or the bottom block's friction, right? That is 15 Newton. So if this value is 15 Newton, the applied force F needs to be definitely greater than 15 Newton for the system to go, right? So we should write F must be greater than 15 Newton so that both the blocks will start to move. Now the question is that means we are considering that the relative sliding between the blocks has not started yet. If we say that the relative sliding between the blocks has not started yet, so can we say that M plus M should be considered as a single block? So can we consider this M plus M as a single block? Yes. So I'm going to consider both of them as a single block, and the net force is F. And here we are going to F2, the maximum value of F2 will come here, that is 15. And if so, and they all will have a common acceleration A. So here we will get the common acceleration A is equal to F minus 15 divided by 3. Net force divided by the total mass, because total mass is coming out to be 2 plus 1 equal to 3. But this is not the question. The question is that we are required to find out the minimum value of F. Minimum value of F. So how to find out the minimum value of F? Okay, so we have two unknowns. So we will be taking the help of another equation. So that equation is this one. If we say that this one is also moving with the same acceleration, right? So this one is small capital M, and this is moving with the common acceleration A, and see the net force that is acting on it is F1. Other than that, no other forces are there. So we can write F1 is equal to MA, and we have already calculated the value of A. So it is going to be M into F minus 15 divided by 3, and F1 is calculated to be 5. This is the maximum value of it at which it was just about to slide, right? So we can continue with the part of this here. So this is going to be M is given as 2, right? 2. So 15 by 2 equal to F minus 15. So F is equal to how much? 7.5 plus 15, that is equal to 22.5 Newton. The answer is 22.5 Newton. I know most of you have, many of you have got the answer as well, I think. Let's check now. Let me check it out. Yes. Answer is option C. Very good. Now question number 30. Can you understand the graph? The graph is between the acceleration and the applied force. It shows the acceleration of the block with respect to the applied force. The mass of the block you have to find out. What are the things that we can identify from the given graph? What are the things that we can identify from the given graph? Yes, very good. I got a correct answer now. That is option C. A block of unknown mass m is at rest on a rock or a gentle surface. Can you see clearly that when the applied force is not equal to 4 Newton, the block is not having any acceleration. The block is not having any acceleration, right? So there is a friction, whose limiting value is equal to 4 Newton. So from the graph, we can see that as F for F is less than 4 Newton, the block's acceleration is equal to 0. So that means limiting value of the friction is equal to 4 Newton, right? When the applied force is equal to 6 Newton, when the applied force is 6 Newton, then we can find the acceleration is equal to 1 meter per second square, right? So if you draw the diagram, you can take any of the force, that doesn't matter. So the mass of the block, we are required to find out. Applied force is given as, let it be 6 Newton. You can also take it as 10 Newton, that doesn't matter. But maximum value of friction is 4. And let the acceleration is a, and the acceleration is 1 meter per second square. So we can write 6 minus 4 is equal to m into 1. So mass is coming out to be 2 kg. Mass is 2 kg. (32). This kind of problems are aptly expected in NEET most of the time. Last year also it came, in JEE Main also it comes. Do it. So this is your case 1 in which we are projecting a block with some initial velocity, let it be u, and it is raising on the, or it is running to some height, let it be, or the length, let it be s, whose elevation is given as alpha. As we know that what is the acceleration on an inclined plane if friction is present? Acceleration is given as g sine theta or g sine alpha minus, I mean plus, this is minus plus mu g cos alpha, mu g cos alpha, because if you draw a free body diagram, we can clearly see that this is mg, this is alpha, and in this direction we will be getting mg cos alpha, mg cos alpha. And if the body is going up, if the body is going up, so the friction is going to be in the downward direction, and the friction is having a value of mu mg cos alpha, right? So these two things should be mg cos alpha, this is sine alpha. So mg sine alpha plus mu mg cos alpha divided by m, right? So this is, but the direction of acceleration is in the downward direction. So this is the acceleration actually. The time of ascent to the upper point was found to be, but you know, when the block is going to reach the upper point, it will be at rest. It will be at rest, so final velocity of it is equal to 0. So I am going to write down the equation as s is equal to ut1 minus half a t1 square. T1 is the time with which it is going up, right? So I'm writing here ut1 minus of half and g sine alpha plus mu g cos alpha t square, mu g cos alpha t square. Apart from that, another equation we can get it for the way up. So this one I am writing for the way up actually. So from this we can also write down 0 is equal to b minus u equal to 80. I am writing it here, u plus 80 u minus 80. So it is equal to 0 u minus of g sine alpha plus mu g cos alpha t2 square, right? T1 square, T1 actually, U80, na? Huh, this is UT. So from this we got the value of U is equal to G sine alpha, because U is not given, no? Plus mu G cos alpha T1 plus T1 into T1, right? This one is U. So we will do one thing, I will take it and put it in the first equation. I'll take it and put in the first equation, later I'll put it later. So now we will talk about the way down. What is happening in the way down when the block is coming down? Time of descent to the initial point, it is found to be half the time of descent. So if the block is coming down, as you know that, we can write down s is equal to initial velocity, let it be 0. If you just release it, it is going to come to the stop. S is equal to ut, or ut is going to be 0, so half. And when the block is coming down, see what is happening? The block has a tendency to move in the downward direction. So we will be getting the g sine theta mg sine phi is in the downward direction, and here it is mu z cos alpha, right? M. I just removed and showing the acceleration. So the net acceleration is in the in which direction? We can write it as g sine alpha minus mu g cos alpha. So this is A2. I'm writing here it as A2. So S is equal to half into g sine alpha minus mu g cos alpha t2 square. T2 square. Clear? This is going to be T2 square. So we got how many equations? This is equation 1, this is equation 2, and this equation also we got. Now can't we compare these two equations? Can we compare these two equations? Now you can compare both the equation. Now you can compare both the equation. And what are the other things are given? It has given the relationship between the time. It has also given you the relationship between the time. It is given the time of ascent is half of the time of descent, like T1 is equal to T2 by 2. Now we can find out the coefficient of friction. I think all of you are getting the answer. Solve it, solve it. Are you getting the answer or not? From both this equation, you can find out T1 and T2. Answer is option C. I'm leaving this task for you. You can solve it later. Answer is option C. All these things I have written it down and you have to compare it and find it out. Okay. $33. Same type of question that we have already done it. We are required to find out the acceleration of the 4 kg block. It gives that there is no friction between the 4 kg block and the surface and the horizontal surface. If the horizontal force is 12 Newton applied on the 2 kg block, as shown in the figure, acceleration of 4 kg block you need to find out. You are required to find out the acceleration of the 4 kg block. Method is same. First of all, we have to draw the free body diagram of all the blocks and show that what are the tendency of the motion of the blocks, and as well as we have to show the direction of the frictional force, find out the maximum value of friction on each one, right? So here we will have a friction here, let it be F1. So its counter will go here, it is F1, right? Counter will go here as F1. So let us find out that, as we know that there is no friction between 4 kg block and the horizontal surface, the friction is only present over here. So let's discuss about the maximum value of friction F1 over here. F max is equal to mu into normal reaction. I'm writing here N1, the normal reaction between this body, I mean this surface and the block. So we can write down mu is equal to 0.5 into 20. That is 4 Newton. 0.5 into 20, that is 4 Newton. Till this, I think everybody must be clear about it. So that is coming out, sorry, this is 10 Newton, this is 10 Newton. Now, let us write down. So to start the sliding between the blocks, at what time the sliding between the blocks will start? When the friction is going to approach this value. Okay, the friction is going to approach this value. So let's write down the force equation for both the blocks. If I'm going to talk about the 2 kg one, if I'm going to talk about the 2 kg one, so what are the forces are going to be applied on it? F is here, and the maximum value of F max, I'm writing here F max, and the acceleration is A. So I'm writing here, as we know that F max, and for the 4 kg, this is F max. And we assume that the both of them are running with the same acceleration because no sliding is taking place. So they are not detached and they are moving like a single body. So in that case, we can write down the first equation as F max is equal to 4A. This is my equation 1. And for the upper one, we can write F minus F max is equal to 2A. This is your equation 2. So when we add both the equation, it is going to be F equal to 6A, right? F is equal to 6A because F max is removed now. Okay, so F is equal to 6A means we are required to find out the acceleration. So what is the amount of force is getting applied? This is your 12 Newton. So equal to 6A. So acceleration is coming out to be 2 meter per second square. It is 2 meter per second square. Clear? So I hope everyone is very much clear that how to deal with this kind of question. I have kept one more question also. Now let's go do question number 35. Yes, very good. Answer is option, no, 35 I'm asking, na? Okay. A load is attached to the end of a spring under an equilibrium produces 9 centimeter extension in the spring. So this is our spring and a load is attached. So the equilibrium is producing 9 centimeter extension in the spring. So I'm just showing it by the dotted line, and this one is going to be 9 cm. So we can write down the first equation is mg equal to kx. Mg is equal to kx, right? So what is the extension here? 9. So I can write mg is equal to 9k. Just I'm writing and putting it here. In the next case, what we are doing, we are cutting it into 3 equal parts. I told you already that KL should remain constant. So that means the new value of K is going to be 3K. Directly we can write 3 parts. N parts means NK. Each part is going to have a spring constant of NK or 3K. Here we are cutting it as. So the next situation is something like this. So they all are the new springs which are connected to the same block of mass M, right? So this is K dash, this one is K dash, and this is K dash. As we know that they all are connected in parallel with each other. So we can write down the 3K dash, and they are all parallel means 3K dash into the new extension that I am writing it as X dash should be equal to mg. Under equilibrium condition, we can write mg, and here it is K equivalent into X dash. So we can write 3 into 3 is 9K, X dash is equal to mg. We are required to find out the new value of extension, that is mg divided by 9k, and from first equation I am going to take it as 9k by 9k. Mg is equal to 9k, so answer is 1 centimeter. That is the answer to the question. For what value of capital M the masses will be under equilibrium? For what value of capital M the masses will be under equilibrium? The vase is a fixed one, so there is no tendency of motion of this vase. So we are required to find out that what should be the value of M for which the masses will be under equilibrium. So if you draw the free body diagram of the system, you can show that along this direction, this is 5, and here we will be getting 5g sine 37. No friction is present. Tension is T. If you draw a free body diagram, here it is going to be T because the string is same. And nothing has talked about the string, so they are having equal, massless and ideal string. So this block is capital M, so here we are going to get mg sine 53. The body is under equilibrium means the net acceleration of the system needs to be equal to 0. As we know that the acceleration is equal to net pulling force divided by total mass needs to be equal to 0. As we know that the net pulling force is this minus this or this minus this, whichever is greater. We can take any of the direction divided by total mass. So acceleration needs to be 0 means the net pulling force needs to be equal to 0. So we can write mg sine 53 must be equal to 5g sine 37 degree. See what are the things are getting cancelled out. M is equal to 5 sine 37 divided by sine 53. Let's check it. Sine 37 is 3 by 5. 53 is 4 by 5. So it is 3 into 5 by 4. So 15 by 4. 15 by 4 is coming as 3.75 kg. So answer is 3.75 kg. Right? Answer is option C. Now the next one is question number 39. A body of mass m starts sliding down on an incline of inclination of 30 degree from rest. Those who all are present in the class today, can you please text me personally that you are present? I will send you some material. Okay. A body of mass m starts sliding down on an inclination of 30 degree from rest. The body comes to rest just when it reaches the bottom. If the top half of the plane is perfectly smooth and the lower half is rough, you have to find out the force of friction. You do it? Right? You require to find out the force of friction. I'll show you that how to do this question by using work energy theorem. Conservation of energy. No, its answer is not B. Its answer is not B. So I'm just naming these points as A, B, and C. Okay, so how much amount of energy was possessed by the body when the body is at A? So we can read that, write down that the total energy of the body that is possessed by it is at point A is mgh. This is mgh, but we don't know that what is the value of h. When it is sliding from A to B, it has some potential energy and some kinetic energy, right? Some potential energy and some kinetic energy, right? But this potential energy is h dash, mg h dash, and kinetic energy is some half v square, let it be. But we can write down that energy at A is equal to energy at B. Okay. So from this point to this point, there is no loss in the energy, only the conversion of one form to another form is there. But when the body moves from point B to C, so all the energy has been consumed by, all this energy has been consumed by the friction, right? So how much energy is going to be consumed by friction? That is equal to the work done by friction. So we can write down work done by friction is equal to frictional force into displacement. Frictional force into displacement. I'm only writing down the magnitude of it, right? So how much is the frictional force? The frictional force is F. I'm writing F. Okay, I'm not writing because we don't know anything about it. I'm just simply writing it as F. And the length for which the friction is going to act is as FL. The length for which the friction is going to act as FL, right? So what were the things that I'm going to write here? So first of all, I have to find out the value of H. By using this triangle, we can see that this is H and this length is 2L. So we can write down sine 30 degree is equal to H by 2L, perpendicular upon hypotenuse. So H is equal to 2L by 2. That is equal to L. H is equal to L. Okay. So we can write down MGL is equal to FL. L and L are gone, so the frictional force is equal to mg. That's it. So frictional force is equal to mg. You cannot use that mu mg cos theta because mu value is not given. So you cannot use that. Next one, question number 40. A mass of 0.5 kg is just able to slide down the slope of an inclined rough surface when the angle of inclination is 60 degree. The minimum force necessary to pull the mass off the incline along the line of greatest slope you have to find out. Very easy. Just draw the free body diagram, we can do it. It is just able to slide down the slope of an inclined rough surface when the angle of inclination is 60 degree. The minimum force necessary to pull the mass off the inclination along the line of greatest slope. So if you are using an external force F on of the plane, so the acceleration will be in the upward direction. I mean, the body will start to move with constant acceleration or with constant velocity, that doesn't matter. But the thing is that it has a tendency to move in the upward direction. Tendency of motion will be in the upward direction. So we will be getting the friction in the downward direction here. That is equal to mu mg cos theta. And here we are having mg sin theta. So what we are going to get? The minimum force. For minimum force means this must be equal to the summation of these two. So we can write down F is equal to mg sin 60 degree plus mu mg cos 60 degree. So all of the values have been given to you. You just put it in the equation. You will be getting the answer. It is coming as 5 root 3. 5 root 3 is 1.732. So it is almost equal to 9 Newton. Even though you do not have to calculate because only one value is there which is very nearer to the answer. Okay. Minimum force required to keep the block of mass 1 kg at rest against a rough vertical wall is P. If a force of P by 2 is applied, then the acceleration of the block we have to find out. Minimum force required to keep the block of mass 1 kg at rest against a rough surface is given. That means it says that when you apply a force of P, the block is held at rest. The block is held at rest. So if you'll show that all the forces that has been acting on the block, this one is the pushing force, and because of that we will have a normal reaction along this direction. So the block has a tendency to move down along this direction with, and downward is 1g or the wound weight. But right, but here the friction is the force which is going to hold the block. So we can write down the frictional force is equal to mu into normal reaction, that is the maximum value of friction here. So we don't know the value of mu. Okay, fine. So but in this particular case we can write mu n should be equal to mg. Mu n should be equal to mg. And what is mu n? What is mu n? And this normal reaction is nothing but normal reaction is P. As you push it now, so the normal reaction is going to change continuously. If you make it as P by 2, normal reaction will become P by 2, right? So we can write down the normal reaction equal to P, and maximum value of friction is coming out to be 0.5 times, okay, mu is given here, like 0.5 times of P. So that is equal to P by 0.5 P is equal to, and what is this value? That is equal to mg, that is 10 Newton. Okay, fine. So from this I got the value of P equal to 20 Newton. From this I got the value of P equal to 20 Newton. In the next case it is saying that the force of P by 2 is applied. The force of P by 2 is getting applied. So when the force of P by 2 is applied in case 2, so in this particular case, if P by 2 is getting applied, so the normal reaction value is also getting changed. And P by 2 is 20 by 2, that is equal to 10 Newton. So what is your normal reaction now? So the new normal reaction is equal to mu into 10. Mu multiplied with 10. Mu is 0.5, that is 5 by 10 into 10. So we got the frictional value, or the normal reaction is 5 Newton. Frictional force. Sorry. This is also in dash, and mu in dash is frictional force. So if you draw the free body diagram, how much amount of force is here? 10 Newton. Friction is 5 Newton. Now the block will slide. So the acceleration is 10 minus 5 divided by 1, that is equal to 5 meter per second square. So this is the answer to the question. $55. Many times it has come. 2 years back also it came. We did it many times. Concept of pseudo force. You cannot, it is not recommended for you that you stand on the road and watch the scenario. You should hop into the box to look at here. But this time the question is different. I mean, you can see that why I took this question, because all the options needs to be checked and you can learn something from all the options, right? You hop into this is the observer. You go into the wedge on the moving wedge. Let it has an acceleration of A, and that is equal to 5 meter per second square. Let's draw the free body diagram of it. So these are the two directions about which we are going to observe the block. One is along this direction, right? So if you draw all the free body diagram of it, this one is mg, right? By default, mg sine theta will come down here. Mg sine theta will come here. We'll put the value of theta later. Pseudo force will be here, like opposite to the direction of the motion, and mass into acceleration of the observer, that is towards right. So MA will give rise to two components now. MA will give rise to two components. See, normal reaction is along this direction, normal reaction is along this direction. So I'm going to show the pseudo force with different color of pen. The pseudo has two components now. Pseudo has two components now. Okay, along this direction we will have two forces. One is mg cos theta, and we will also get one of the component of the pseudo force along this direction and along this direction. So the component of pseudo force along this direction is going to be ma sine theta, right? Because this angle is theta, this angle is theta. So this is 90 minus theta. So this angle is going to be theta. So we are going to write here ma cos theta, and here it is ma sine theta. So these two will be balancing the normal reaction. It will not allow the block to move along this direction. And these two things needs to be equal, right? So we can write down the normal reaction is equal to, we can write down the normal reaction here is equal to, we can write down the normal reaction is equal to mg cos theta plus ma sine theta, right? So this is one of your equation. This is one of your equation. And the second one, we are going to find out the normal reaction as, what are the values are given? 2, 10, cos 30 is cos 37, cos 37 is 4 by 5 plus 1 into 5 into 3 by 5. So when you add all these things, we are getting it as 11 Newton, right? So it is given that the block cannot remain stationary with respect to waves or not, that we need to check. We have to check that that block will remain stationary with respect to waves or not. For the block needs to remain stationary with respect to the wave. So first of all, we have to check that whether mg sine theta is greater than ma cos theta or not. So for that, I'm checking it for option A. Look at this question carefully because we have to check for all the options. So first of all, I have to find out mg sine theta. Mg sine theta is coming out to be 20 into sine 37, that is 3 by 5. That is how much it is coming? Mg sine theta is, m is how much? 1 kg, sorry. Right. It is 1 kg. So this one is coming out to be 12 Newton. Is 6 Newton. 6 Newton. Similarly, what should be the value of ma cos theta? Ma cos theta is coming out to be 1 into acceleration is 5, cos 37 is 4 by 5. This is 4 by 5, that is 4 Newton. Okay, can you see that mg sine theta is greater than ma cos theta? Is greater than ma cos theta. So the block will not remain stationary with respect to the wedge. So the first thing that we are going to find here is block is, this is 1 actually, this one is 1, this is also 1. So mg sine theta is greater than ma cos theta, so the block will not remain stationary. Will not remain stationary. So this is our first option. Now let's find out the acceleration of the block with respect to the wedge. Acceleration of the block with respect to the wedge. So what should be the acceleration if it is not stationary? So we can find out the acceleration is equal to, just a minute. So we can write down the second option. Acceleration of the block with respect to wedge is net force divided by mass. So here the net, which one is more? Mg sine theta is more than ma cos theta. So we can write mg sine theta minus ma cos theta divided by m. So this is 6 minus 4 divided by 1. 6 minus 4 divided by 1, that is 2 meter per second square. That is 2 meter per second square. We got the answer as option C. So this is the answer to option C, right? Okay. So that's why answer is option C. So this is a complete package questions that we just validated all the answers. Now this is question number 61. Read the question carefully. This is a very nice question. If you miss it and we'll start doing like acceleration directly, look at the figure and get happy and do it, then you're going to get the wrong answer. A block of mass m on a horizontal smooth surface is pulled by a load of mass m by 2 by means of a rope AB. So this one is a rope AB and the string BC are shown in the figure. Can you see? It's a very interesting fact that the length of this rope is also given to you. The length, mass of this rope is given to you and the length is given as L. And the mass of is this is m by 2. So in initial situation, if we wish to find out the acceleration in case 1, when the at this particular condition, so in case 1, the net acceleration is equal to net pulling force, F pulling divided by total mass to be pulled. So along with the two blocks, the mass of this rope will also be included. So in first case, the A1 is equal to F pulley. Pulling force is m by 2g because these two are on the horizontal plane. So divided by the total mass m by 2 plus m by 2 plus m. So this is 2m. So it is m by 2g multiplied with 2m. See, m and m are gone. So we are getting g by 4. We are getting g by 4 meter per second square. Now let's come to the second case. It is given that as the block is pulled from AB from L to AB equal to 0. AB equal to 0 means this block must have come to this position by that time, and this part of the string should come down. This part of the string should come down. So if you draw the situation here for the case 2, if we draw the situation over here for case 2, so the case is going to look like this. Here in this particular case, we will be getting, so this part of, it's not spring actually, this is a thick row. This is m by 2, and this block is somewhere over here, and this is m by 2. So this time the pulling force is going to be changed. It is mg now, because m by 2g plus m by 2g, that is mg. So A2 will become net pulling force, that is mg, divided by how much? Total mass is 2m. Total mass is 2m. So this time the acceleration is g by 2. This time the acceleration is g by 2. So the answer is from g by 4 to g by 2. Answer is option B. That is g by 4 to g by 2. Clear? $62. What should be the minimum value of capital M, maximum value of capital M? Show that 4 kg block does not sleep over the 5 kg block. You require to find out the 4 kg one should not sleep over the 5 kg one. That means they both should move with same acceleration. They both should move with the same acceleration. So we have to say that, we can say that both of all of them should move with common acceleration. So in that case, if you draw the, so the force, this is I, and this one is A. So we can write down the common acceleration here is net pulling force, that is mg, divided by 9 plus m into z. So this is your common acceleration. Let us analyze the situation with the free body diagram of 4 kg block. If this block has a tendency to move or sleep on the 5 kg block, so it has a tendency to move in the backward direction. It has a tendency to move in the backward direction. So that means if you draw the free body diagram of 4 kg, so you'll have the friction on it towards right. So this maximum value of friction is coming out to be mu times of N1, and N1 is 40, right? 4 kg blocks of 40. So it is how much? Mu into normal reaction, that is 0.4, that is 4 by 10 into 40. So this is coming out to be 16 Newton. This is coming out to be 16 Newton. Clear? This is coming out to be 16 Newton. So, and you know that this, if this is also moving with an acceleration a, we can write down the equation here of force is F max equal to a. We can write 16 is equal to 4 times of a. So we can write 4 into the net acceleration, that is the common acceleration mg, divided by 9 plus m should be equal to 16. So on solving this, we can write 4 mg, that is 40 m equal to 16 into 9 plus m, right? So let's solve it, or we can simply cut this here. This is coming out to be 36 plus 4m is equal to 10m. So 6m equal to 36 and m is equal to 36 by 636 kg. That is 6 kg. So this is the answer to the question. Now I think everyone is very much clear that how to deal with the two block problems. 65. This is a very easy one. The situation is something like this. The initial separation of this M with the ground is given us here, and this is 1 meter. The block is originally at rest at a height of 1 meter from the ground, and we are releasing if the hanging block strikes the floor 2 seconds after the system is released. The hanging block is going to hit the floor after 2 seconds of its release. So we can write down the weight of the hanging block we have to find out. We are required to find out the weight of the hanging block. So for this block, we can say that the initial velocity is equal to 0. Acceleration is 10 meter per second square. As acceleration is, we don't know the acceleration, right? We don't know the acceleration, but we have to find it out. And displacement is 1 meter. So we can write S is equal to ut, and time period is given us 2 seconds. S is equal to ut plus half at square. We can say that ut is equal to 0. So displacement is 1 equal to half. Acceleration we don't know. We are required to find out. T square is 4. So acceleration is coming out to be 0.5 meter per second square. 0.5 meter per second square, or 1 by 2 meter per second square. Now we are required to find out the weight of the hanging block. Now how to find out the weight of the hanging block? So all the forces that has been applied over here, if you draw the free body diagram of all the things here, so what are the forces are there? An internal force of tension is also, you'll be getting it here. So here is tension T. So for this block is also acceleration is 0.5 because of the constant motion. The same string is attached to both the blocks. So we can write down the tension here is equal to 20 times of A. So 20 into 1 by 2. So we got the value of tension is equal to 10 Newton. If you got the value of tension is equal to 10 Newton, draw the free body diagram of the small block M. Draw the free body diagram of small block M. So we can show the all the forces, that is mg here. Tension is in the upward direction. Acceleration is here. So we can write down mg minus t is equal to ma. So we got the weight of the hanging block. Now we can get the weight of the hanging block. So what is the weight of the hanging block? That is mg. So mg is equal to ma plus t. Ma plus t. So but before that we are required to find out the value of m. But before that we have to find out the value of m, because m is unknown to you. So we how to find out the value of m? Same thing, na? From this equation itself we can find out the value of m. Wait. I can write 10m minus t, that is I have already calculated it out to be 10, equal to m into acceleration is equal to 1 by 2. So we can write 10 is equal to 10m minus 0.5m. 0.5m is 9.5 m equal to 10. So m is equal to 10 by 9.5. 10 by 9.5. So this is 100 divided by 95. 100 divided by 95, that is coming out to be 20 by 19 kg. That is coming out to be 20 by 19 kg. Okay. So we can find out mg clearly, easily now. 20 by 19 into 10. So 200 by 19, that is equal to 10.35. 10.35 sorry 10.53. 10.53 we are going to just round it to be 10.54. So this is the last one. Let's do it. Easy Conceptual one, that's why I put it. For the arrangement shown in the figure, the tension in the string prevent it from sliding down. Great. So let's first check that whether this can be slided down or not. It can be slided down or not. If you draw the free body diagram, we can see that whether if the body slides down, so we can say that what is the maximum value of friction and what is mg sine theta. Mg sine 37, first of all we have to find out. 1 into 10 sine 37 is 3/5. So this is 6 Newton. So if you find out the maximum value of friction, this is mu mg cos 37. So what is the value of mu? 0.8, that is 8/10, that is 8/10 into m is 1, 10, cos 37 is 4/5. Right? So this is 32/5. 32/5 is coming out to be 6.4 Newton. This is 6.4 Newton. 32/5 is 6. So here friction is stronger than the pulling force. F max is more than 6 Newton. That is more than 6 Newton. So first of all, the block will not slide. If the block will not slide, so any of the tension will not be there. The tension can only be produced now if the block will start to try to be in the downward direction. The friction will hold the block. So the friction will not allow the block to slide. Friction will not. Why I put this question? Because most of the students will do this thing. They will write mg sine 37 degree, then they will put the frictional force, then tension, and directly try to find out the tension. But this thing will not come to mind, that whether the block will try to slide down or not. Friction will not allow the block to. So no tension is required now. Friction will not allow the block to slide. So that's why answer is option D, that is none of this. So after the class, please send me how many of you are present in the class. Separately, you send me a message in Telegram group. Thank you.